In the ever-evolving landscape of technology, one innovation stands poised to redefine the future of computing. This is the story of quantum computers, a revolutionary leap from classical systems that could transform our world. Welcome to the Tellus as we embark on a journey into the quantum realm. From its groundbreaking principles to its transformative potential, we'll explore how quantum computers work, the challenges they face, and their impact on our lives. Let's begin our exploration of this extraordinary technology. Quantum computing has its roots in the early 20th century, emerging from the strange and counterintuitive world of quantum mechanics. First, let's find how classical computers are different from quantum computer. General-purpose machines capable of performing a wide variety of tasks, including calculations, data processing, multimedia processing, networking, and more. They basically involve maths and computing. Hence, all these devices are in the category of classical computers. Let us come to what is meant by classical, anything which is of a slightly old style. These computer devices may seem very modern to us, but the principles of electronics and computer science in them are based on traditional and old physics. Hence, all of them are called classical computers. In classical computer or digital computer, every information is coded in numbers, and that too only two numbers, 0 or 1. Audio, video, text, or any kind of data is basically a code made of 0 and 1. This is called binary coding, and in this coding, the smallest unit of information, the most basic unit, is called a bit. Just like a house or building can be made by joining bricks, similarly in classical computer, every kind of data or information is made of a bit. For example, understand the binary code for the English alphabet A. The code made of bits is what you are seeing on the screen. There are a total of 8 bits in which A is coded. Similarly, every letter, digit, color, and frequency of sound, etc. can be ported in many bits. In classical computer, bit is the basic unit of information, and it can be only 0 or 1. By joining bits from this, bigger types of memories are made like 8. 1 bit is formed by combining bits. 1,000 bytes are combined to form a kilobyte. Then, megabytes, gigabytes, etc. are formed from them. We call them KB, MB, GB in short. All these are units of digital information, because quantum computing starts to become different from this level of bit. In quantum computers, qubits are used instead of bits, and the value of a qubit is not fixed on 0 and 1. Every qubit is in a superposition of 0 and 1. Let us try to understand this with the help of a coin. Suppose a coin is a classical bit, then just like a bit has only 0 and 1, similarly a coin also has only head or tail. It has only 2 states, heads or tails. Similarly, bits have 0 and 1. If it is spun, it will not be fixed in any one state. And a spinning coin is neither heads nor tails. It is always in a superposition of heads and tails. Like this spinning coin, a qubit is also in a superposition of 0 and 1. While a classical bit can be in only one state of 0 or 1 at a time, a quantum bit is in both the states at the same time. This is the superposition of the cubed, the superposition of quantum mechanics. There is a basic principle in nature that at a very small level, this is at the quantum level, nothing is permanent. Nothing has a fixed state. At the quantum level, everything has many possibilities. The existence of many states at the same time is called superposition. A quantum bit, this is a qubit, is in a superposition of 0 and 1 states at the same time. But this superposition lasts only till someone does not observe it or there is no external interference in quantum mechanics. When a quantum particle is observed, this superposition can end. The world that exists in a mixed state reveals itself in a definite form when observed. If you take the measurement or observation of a qubit, then either 0 or 1 state will be seen in it. It means that when an observation is taken, the spinning coin stops and either head or tail is seen in it. But as long as this coin is away from the outside world or observation, this superposition lasts, and this superposition is very difficult to calculate. Very few things are available in the world of computing. Very good things can be done by using the superposition of these qubits. A single qubit will not be able to achieve much, but the real game begins when many qubits come together. Quantum computers, their unique abilities, let's say for example we have 2 qubits and 2 traditional bits. For both of these systems, we have the options of 0, 0, 0, 1, 1, 0, and 1, 1. So, for different states of the system itself with 2 classical bits of information. But the qubits also have that superposition of each of those bits as well to work with, so you would get the equivalent of 4 classical bits of information to represent each of the possible states. We would need 4 numbers to know the state of the system versus the 2 numbers for the classical one. If we added another bit and qubit to these 2 systems, we would get 3 bits of information for the traditional system but 8 for the quantum system, and it's this exponentially more bits of information that continue to the tune of 2 to the nth power, where n is the number of qubits. So you can see pretty quickly how much more power can be gained from this system exponentially. For quantum computing, another magic is done with qubits, and the name of this magic is entangle. Entangle means things being connected with each other. Entanglement is also a core concept of quantum mechanics through which any 2 things can be connected with each other. There is always an invisible connection between these 2 things, and if the state of one is disturbed, the state of the other is also affected. The amazing thing is that this connection is established instantaneously. It does not take any time. For example, if 2 rotating quantum coins are entangled, then their superposition state is connected to each other. If one coin is dropped, then its direct effect will be felt on the other coin immediately. When qubits are entangled with each other in a quantum computer, their states are forever connected with each other. The advantage of quantum entanglement in computing is that a mathematical relation is formed between the entangled qubits, and all the qubits are locked in a mathematical formula. And this mathematical correlation takes computing to a different level. The thing is that in order to see the output of the problem we solve, we will have to take measurements for it, and when we take the measurement, the superposition of these qubits will be lost and they will look like classical bits. The final output will be in the classical bits arrangement like 0s and 1s. The final output that is coming out of this quantum computation should not be any random positions in the classical arrangement. It should not be any random output. It should be the correct answer to the problem. That means we have to ensure that and the measurement of the output is taken, it should give the correct solution to the problem. To ensure this, a third element is added in the quantum computer, which is called quantum interference. Through this, we can give a direction to the qubes without any disturbance. Imagine trying to solve a massive jigsaw puzzle. A single person working on it might take weeks, but if you had thousands of people working on different sections at the same time, you'd complete it in minutes. That's how quantum computers function, by dividing a problem into smaller pieces that can be solved simultaneously. We're on the cusp of integrating quantum computing with classical supercomputers. Quantum computers operate on completely different principles, using quantum bits or qubits to perform calculations exponentially faster than today's machines. This could revolutionize fields like cryptography, chemistry, and artificial intelligence. While we're still in the early stages, the potential of quantum computing to change the world is immense. The coming years will be crucial in determining how this technology will shape our future. With great power comes great responsibility. Quantum computing raises important ethical and societal questions about its impact on security, privacy, and the job market. It's essential to consider these implications as quantum technology evolves and becomes more integrated into our lives. Quantum computing is a transformative technology with the potential to redefine the boundaries of what's possible. From its revolutionary principles to its real-world applications, the journey of quantum computing is just beginning. Thank you for joining me on this exploration of quantum computing. If you enjoyed this documentary, be sure to like, subscribe, and hit the notification bell to stay updated on our latest content. Share your thoughts and questions in the comments below. I'd love to hear what you think about the future of quantum technology. Until next time, stay curious and keep exploring the frontiers of science and technology. See you in the next video.